So let's see, Kenji. You have some graph paper? I do. I'll give you some. Graph paper?
Yeah.
Yeah, I'll give you some. Kenji. Let me just scoop this. Can you see this here, right here?
Yeah.
Okay, this is called the bell curve, which talks about like our statistical probabilities of something happening. I'll get into this just a second, but I would like for you guys to copy this bell curve, okay? Copy that bell curve. Miss, how's everyone? Woo! Yes.
Why is it called a bell curve?
Why is it called a bell curve? I don't know. Yo!
Hey.
That's what I'm talking about, right? That, right?
You know what that means?
Spank that problem. Is that inappropriate?
It's a little weird. But what I was going to say was, whoever invented the name of that bell curve was lazy, and they couldn't think of something creative.
There's a lot of lazy people in the world.
A lot of lazy math.
Miss Howell says that's a lazy name. Maybe you can think of a better name than bell curve. Not you, but I'm just saying. If you want to, can you think of one? Right? I don't know. If anyone can think of a better name, I'd call it a Batman curve.
Why? I call it a roller coaster. A Goliath curve.
But you see, it doesn't look. It shouldn't look like it, though.
Oh, you're right. That's lazy.
So it doesn't look like Batman.
That's
Batman
true.
is cool.
What if they just call it the statistics curve?
Oh, I think that's more lazy, actually.
Oh. Okay, I'll take it back.
I don't know. Maybe not. Look at you guys.
I did see one this month, but I couldn't find something else.
Oh, no problem. I got tons. I'd be happy to give you draft. I already have them. Oh, you just.
Yeah.
How many do you want? I'll give you.
Like 3.
Okay, a couple things. Once you have this copied down, a couple things we have to understand here. This, let's see, how do I describe this? So, like, we use statistics to tell, like, what is the probability, like, what are the chances of something happening? Like, if we took, like, say you had the whole population of Oxnard High School, and you took all the boys, and you took the height of the boys, okay? You measured the height of the boys, you would have, a percentage of the height would be measured under this curve. So for example, this is going to tell me how tall a lot of boys are. What do you mean by that, Sensei? Well, as you get closer over here, this will be very, very, very tall boys. This will be very, very, very short boys. And everything else, the average will be right in the middle. And most of the boys will be the average height. So there's going to be some very tall boys, but there's not going to be very many very tall boys. But there's going to be most of the boys will be like an average height. So what we're going to do is under here, we're going to put, I want you guys, this Greek symbol, it's like the letter U. That letter U, so write that down. That letter U is called the, is the Greek letter pronounced mu, like what a cow says. But this is going to represent the mean. The definition of this is, it is the mean. You guys remember what mean? You guys remember what mean is? It's the average, right? So the very center of the bell curve is going to represent by the mean, whatever you're measuring. Like we talked about height, you could talk about weight, you could talk about grade scores, right? That's why they talk about, oh, the grade distribution is a grade score. Most, very few people get A's. You'll have an average amount, and very few people will get really very, very bad grades. In the middle of our grades will be our average. And most students should get the average, right? Because the average is the average. Now, this bell curve is called the normal distribution. Most data will look like this. Again, where you have the most people that are the average, and and very small people on this end, and very few of the data will be over here. Very few of the data will be in the lower part, right? So this is also called a normal curve, or a bell curve. Like what Miss Howell said. Okay? Now, we also have this letter, which is little kind of O with a curly on it. This is called our sigma. And this is our standard deviation. Standard deviation is going to be like sort of the average from the distance from the average. So if you notice here, this is my average, and then here will be the average plus one standard deviation. Hopefully you can see that there. And then this section will be the average plus two standard deviations, or plus two sigmas. And then finally, the last one will be the mean plus three standard deviations. And then going in this direction, this will be the average minus one standard deviation. This will be the mean minus two standard deviations. This will be the mean minus three standard deviations. Okay, so make sure you have that whole, you're going to need this normal distribution bell curve in order to do today's assignment. I'm going to leave this up here for you guys so as we do a lot of the problems, okay? Now, as we have this, write these down. To get this is 34%, 13.5%, 2.35%, and 0.15%. This is the probability that this data will fall under this section of the standard of the normal distribution curve. So if you are between the mean, and if your data is in between here, there's a 34% chance that will happen. This is 34% of your data will be under here, 13.5% will be under here, 0.15% will be under here, so forth and so forth, okay? So you guys need that information. All right, are there any questions so far? I think when we do problems, it'll make more sense. But as far as this curve goes up, hopefully we're good with that. Are there any questions before we get on with the assignment? 3 through 25 odd. Okay, let's go ahead and do it. Let's do number 3. Oh, you know what? Can I get both up here? Let's see. Give the percent of the area, the normal curve represented by the shaded region. Okay, so number 3. So I'm going to try drawing these really quick. Hopefully this will make sense. But I think it's pretty straightforward. If I could get another, actually, maybe I can go like this. I'll draw my other curve here so that we can see. So on number 3, where's my
Right there.
Oh, there's one there too. I have 2 of them. Maybe one's better than the other. Okay, let me draw this real quick so we can look at our problems here, like number 3. And then you just calculate the percentage under the curve. So here we go. I'm going to use this as my general thing. And we have here our curve. Okay, I'm looking at number 3. And number 3 tells us what is, in exercise 3 through 6, give the percentage of the area under the normal curve represented by the shaded region. So another important thing is here, these percentages, 0.15, 2.35, 13.5, 30, all of these add up to 100%. Okay, so they add up to 100%. So number 3 asks, what's the probability? Number 3 asks, what's the probability of it being this, 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 and that? What is the percentage there, right? So what's the percentage of this plus this plus this plus this? Now you can add all these up. You know it's half. So go ahead and add that up. What is the percentage of that area under the curve in number 3? What is the percentage? Some of you don't even need to add it up, but I'll give you like 30 seconds to figure it out. Number 3, what is the percentage of this area under this curve? You know, and you can add those up. And then you let me know, okay? I'm going to bring up number 3 so you can see. Make sure you guys can. We're on chapter 10. When this school year's going to end soon, does it feel like it's crazy? That's crazy. Did it go by fast for you? It went by slow? Or you can really...
Oh, yeah, like knowledge that I'm going to be doing this year.
Knowing that you're going to be a junior is surprising, but it's still effective.
Yeah.
I know you mean, yeah, I understand. Depends on how you look at it, I guess is what you're saying, right?
Yeah, okay.
Juniors. Yeah, my daughter's going to be a junior too. That's crazy. Okay, there it is, number 3. Okay, so what is the probability of that? Let's go with Aaron. Where am I? Aaron Miguel. Aaron Garon. What is
50?
What's that?
50?
Yeah, 50%. You don't know if you get 50%. Okay, so you see number 5 here. You have this little section and that little section. What's the probability of that? So you guys see this here? Number 5. This one and this one. What's the probability that you'll have? What's the percentage of that area under the curve? Those 2. All right.
5.
What's that?
Oh, it's 2 of them.
Yeah.
I think 2.5.
Yeah. Add those up. That's it. All right, you got it? This is no problem, right? So what's the area of those on number 5? Let's go with Anthony Campos. What'd you get for number 5? This one here and this one here. Can you see it?
2.5?
Yeah, this one and this one. So you look at the, yes, 2.5, right? Which basically is this and this, right? This is 2.35 plus 0.15. You're adding those 2 up. You guys see that over there? You're adding those 2. This little one here and this little one there. You're adding those ones. Okay. Now it's number 5. So now, if you look at 7, okay, 7 says, what's the probability, this P here, number 7, so here's number 7. P, what's the probability, or what is the area under the curve, under our normal distribution curve, of x less than or equal to, x is less than or equal to the median minus 1 standard deviation. So what are we looking at here? It's everything less than or equal to this, the mean, I'm sorry, the mean minus, not the median, the mean minus 1 standard standard deviation. So you look here, it would be here, and everything less than that. Everything less than that point right there, okay? So, right? So what would that be? What do you guys got? What did you get, Alex, for that one? Yeah. Dun, 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 dun.
5.6.
What's that?
5.6.
No, it's everything less than this.
Number 7.
Number 7.
I got 0.16.
0.16. How did you get that? Wait, let's see. Well, tell me what you did, 'cause maybe. Oh, yes, you were right.
Really confused.
Huh?
So what do you have to do?
No, you're right.
Yeah.
You're right. Well, whatever you did, do you know what you did or no?
No, I don't know what I did.
Well, you just added these up. It was everything less than this. You added this area, 13.5 plus 2.35 plus 0.15. But it's in percent, so it's actually,
But I add them up.
yeah,
Doesn't that turn out to like 16?
yeah. You said 0.16, which is the same as 16%.
Oh gosh. Okay.
You just moved your decimal over. If you looked at the decimal, you're right. Let's see if anyone's paying attention. Alexis Romero, what'd you get?
I don't really know how to do it.
Oh, shoot. Darn it.
Like, I'm not understanding how to do it.
What's that?
Like, I don't understand how to do it.
Alexis, do you
Yeah.
understand? Did you have this written down?
Yes.
Okay, cool. Alexis, do you understand what this is asking?
No, that's what I don't understand.
Okay, cool. So, do you see this? X?
Yeah.
What is the probability that X is going to be less than the median, the mean, minus 1 standard deviation? So, do you see this anywhere on the curve?
Yes.
Okay, I'm sure you see it right here, right? Can you see
Yeah.
my my ruler pointing to that?
Yes.
Okay, so what is anything less than this? So anything less than this would be, well, less than would be in this direction, right? This direction. Anything less than would be this, this, and that. The area of this, the area under that, the area under that. So basically all it is, Alexis, is you just add these numbers, the area under this up. You see the area of this is 13.5, plus the area of this is 2.35, plus the area of this is 0.15.
Okay.
No? Yes? No?
Yeah, I see it.
Okay. That's all you do. Just calculate the area under the curve, and that'll give you the probability of that event happening. That's all we do is just calculate the area under the curve.
Okay.
All right, very good, Alexis. Okay, so what's my answer? Liz, Reyes, what's my answer for my probability of X being less than the mean minus 1 standard deviation?
I don't know.
Well, Alexis will help you, right, Alexis? We just add these up, right? Did you add these up, Alexis?
No, I'm doing that right now.
Okay, cool. Daniel Reyes, what did you get?
16.
16%. Right, anything less than this, you just add 13.5 plus 2.35 plus 0.15. You get 16%. That's all you got to do. Sigma,
Not that one.
mu,
Mew, okay, yeah.
like what a cow says.
No, like Mewtwo. Mew and Mewtwo. Pokemon.
U2.
Mew.
Do you ever do Pokemon Go? There's this, before you guys were born, there's this game called Pokemon Go. Ever played that?
Yeah. It was
One
super
time I was
popular,
playing it, I
like-
got run over by a train because I was trying to find.
No, you didn't. It was super popular like 5 years ago.
Well, how old are you guys? Are you guys over 5?
Pokemon Go is still pretty popular, actually.
Pokemon Go?
Yeah.
On my game on it.
Do people used to walk around going like this though? Like, what's up?
Everybody was doing it.
Is that the way they still play it?
People do stuff like, yeah.
But they walk around like this with their phone trying to.
There were drive dances too.
I kind of want to play it now.
But now it has all the new Pokemon. So when it first came out, it was the original 150 Pokemon.
Yeah, it was just the Johto Pokemon. Sorry, not Johto, Kanto. But yeah, all of them are in it now.
Yeah, so that's annoying. That's no longer nostalgic for me. Those other Pokemon didn't exist when I was a child.
Got to catch them all.
But there used to be 150.
There's
Now
too much
there's
variety.
Too many.
Yeah, Alolan Executor.
So it's lame now.
Not really. Some of the newer Pokemon look really cool.
Well, then why
Yeah,
would
look at the Alolan Executor.
What's the answer to number 9? Let's do 9. We're
What
getting
is it?
distracted.
What's number 9?
Let's do 9. Kyle's is watching. What's the probability? Number 9. Everyone, so I'm going to call on you. Tell me what the answer is. That x is greater than
Ooh, greater than.
mu plus 2 standard deviations.
What?
So where would that be on our little normal distribution
Bell curve.
statistics bell curve?
Yeah, Batman.
Batman. Okay, so I'm going to call, what is this? Is it right? 1 standard deviation greater than that direction. That's all I'll say. Go ahead and find the answer. I'm going to call on one of you. I'm calling on one of you. All right, here we go. I'm calling on you at random. Kana Olaso. What'd you get, Kana?
2.5%?
Here we go, 2.5%. That's it, right? You guys get that? 2.5.
So what you do, you go like this, you look for this, the greater than
This right here.
this.
What's the
So you
probability?
find this on here,
Yeah, and then so
and that's
add
this
and
line
that.
right there. So you add up the sections that are greater
Yeah,
than.
that's everything. That's the area under the curve. that
So
is
this
greater than-
section is the 2.35, and then that section is the 0.15.
Yeah,
So you add those two sections together.
yeah,
Oh,
that's it.
that's it. That's not too bad.
No, it's not too
The
bad.
Greek letters make you think it's going to be confusing.
It makes it seem like it's in Greek or something.
I mean, it is in Greek.
Oh, shoot, it is.
Yeah.
So I guess you can't use that.
Do you know your Greek alphabet?
Yes, you
That's the American alphabet, or English alphabet.
Alpha, beta,
Uh-huh.
Canada,
No.
Canada.
Did you have to memorize it?
No, why?
I don't know.
For math?
Yeah.
I wasn't a math major. Did you have to memorize
I
it?
had in 7th grade, yeah.
I never had a.
You had to stand in front of the class and say the whole Greek alphabet.
Oh, okay, go ahead, say.
Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, something, 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 omega.
Better than I could do.
Oh, like,
Alpha, Bravo.
yeah, Alpha, Bravo, Charlie. No, I don't know them all.
Delta.
I only know the first 3. I don't know.
Delta.
All right, let's do 11. Actually, you guys can do the rest on, I don't know.
Good luck.
All right, thank you.
How you doing?
Okay, so number 13 through 18. So what it says here is a normal distribution has a mean of 33 and a standard deviation of 4. Find the probability that the randomly selected x value from the distribution is given in the interval. So I'm skipping 11, you guys do 11, but basically what this is telling us the numbers to put in front of the bell curve, right? So I have this bell curve here, like it tells us a normal distribution has a mean of 33 and a standard deviation of, so I'll put this up so you guys can see it. And AV mute, let's see here. So, and all you do is just fill in the bell curve. Try to find 11. Was it 11 or 13? Okay. Ooh, I need this here. Can you guys read this? Okay. So what this is basically saying. I haven't lost everything. I still have my shoes.
It's on the floor.
I lose a lot of things. Actually, I don't really lose a lot of things, I have to be honest, but sometimes my stuff goes around, you know what I mean? What are you doing? Okay. Oh, okay. I thought you were playing Pokemon Go. Got inspired. Next exercise, a normal distribution has a mean of 33. So let's fill in what we know. Has a mean of 33. So where would the 33 go, right? The mean of 33 would be right here in the middle. It says here, normal distribution has a mean of 33, right? And a standard deviation of 4. What does that mean? Remember, this was +1 standard deviation, so this would be 37. How did I get that?
Yeah.
Because it's standard deviation of 4. I add 4, so what would this one be? 41. How did I get that?
Did you just add 4?
Yeah, that's what the standard, it means each from the mean, I add 4 each standard. These are each standard deviation, I add 2 standard deviations. So this would be the mean plus 2 times it. So it would mean plus 8, right? This plus 8. And then I add, so what would this one be here? 45. And then I go 29. How do I get that? Yeah, subtract 4. So this would be 25. This would be 21. Okay? So we set up our bell curve, right? So a number, can you guys see me? I don't know if you guys can see me here. Connor, can you see me?
I just had to pin you.
Huh?
I just had to pin you.
Okay, because I'm going to stop. I'm like looking at both. So I'm going to show you guys both. I'm trying to teach both you guys online and then the students in the classroom. But what this tells me, I set this up, tells me my normal distribution has a mean of 33. So my main thing is 33 and a standard deviation of 4. That means I add 4 every time. 33 plus 4 is 37, plus 4 is 41, plus 4 is 45. Then this way I take away 4, 29, 25, 21. Okay? So this tells me how to set up my bell curve. And now I can answer these questions. Find the probability that a randomly selected x value from the distribution is in the given interval. So, what's the probability that I will select 29 to 37? So between here and here, what's the probability that I would get that? Well, that's minus 1 standard deviation and plus 1 standard deviation. It would be from here to here, which would be 68%. So that's the answer. 68%. Okay, that's how you do it. You got to set up the bell curve in order to do that, which you got to do for your test, which is on Thursday. Test is on Thursday, not on Friday this week. At least 25. What the heck does that mean? At least 25? Does that mean it's bigger or smaller than 25? At least? I think it's bigger. At least. You are at least, to be in high school, you have to be at least 14. That's the smallest. Or 13, right? You have to have at least $10 in order to be my friend. Does that mean you can have $9? You have to have more than $10. So at least 25, which means 25 or bigger. So it's this one plus 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 this one. 25, so it's 2 standard deviation for here, 13.5 to 34 plus 34 plus 13.5, 2.35 to 0.15. You guys get it? I think that's pretty self-explanatory. That's 15. So 17 is the same thing at most 37 at most. At most. That means you can't, it's 37 or less. Because you can have at the most 37. That's the way I understand. Okay, 19. The wing lengths of houseflies are normally distributed with a mean of 4.6 millimeters, a standard deviation of 0.4. So let's look at 19, and then we go up to 25. Okay, I think we're pretty much doing good. Should I do 19? 19's like the same thing. Can I move on? Laura, how am I doing? Can I move on to 19, or do you have questions?
I don't have any questions.
Okay, so should I move on? Am I going at a good pace? I'm just trying to get your opinion for the class.
Yeah, we can move on.
Are you learning anything today, or am I doing a bad job teaching? Be honest.
No, I am learning.
I feel like I'm not entertaining you guys as well. Am I being boring today? I think I'm being boring. Don't answer that, because I'll put you in a bad spot. Lily, am I being boring today? I think I'm being boring. I'm sorry. You don't have, Lilia, you don't have, Madrona, you don't have to answer that. Just tell me, how are you feeling today, Lilia?
Good, how are you?
I'm good. Okay, Lilia, hey, look at this one. Problem solving. Is it? I'm trying to get it right here. Okay, the wing length of houseflies are normally distributed with a mean of 4.6 millimeters. So what does that mean? Where did I put the 4.6?
In the middle.
In the middle, right? So 4.6 will go here. 4.6. And a standard deviation of 0.4. So guess what? Right?
Yeah.
And then 5.4, right? And then 5.8. And then, right? What goes here? 4.2. And then
3.8.
3.8. 3.4. Then you can just answer the questions. About what? It says about what percent of houseflies have a wing length between 3.8 and 5.0, right? So, 3.8 and 5.0, right? So you just add this, this, and that, right? That's all you do. I think that makes sense.
Yeah.
So I think that's that. I'm gonna move on. That's 19. 21, find the error analysis. Find the error analysis, 21. And so I gotta keep this here, but I want you all to see. Next exercise 2022, normal distribution has a mean of 25 and a standard deviation of 2. Oh, look at here. I can already see the mistake. What's the mistake?
They only added the.
Yeah, exactly. Hey, Emily, what's the mistake on 21? Can you see? Should I put it on the screen for you to see?
No, that's fine.
Okay, what's the mistake then? Emily, tell me what the mistake is. Can you hear me? Did I go out? I thought I heard you talk.
Oh no, I can
Oh,
hear you
I
just fine.
froze.
I can hear you just fine.
No, I'm frozen. My computer freezes. Emily, can you hear me now? I froze.
Yes, I can hear you.
Okay, sorry. Okay, Emily, what is the mistake here in this? In exercise 21 and 22, a normal distribution has a mean of 25 and a standard deviation of 2. Describe and correct the error in finding the probability that a randomly selected x value is in the given interval. Okay, so it has a mean of 25 and a standard deviation of 22. What's the mistake there, Emily? Did I freeze again?
No, you're fine. I don't know.
Emily, look here closely. What does this say about the standard deviation? Right here, look what I'm highlighting. What does it say?
It's 2.
Okay, so what does it say about the mean?
It's 25.
Okay, so let's put the 25 here. Does that make sense? That looks good. And then should this be 26? Or do you know? Should I call someone else?
Yeah.
Okay, stay with me. Let's say, Eduardo, help Emily out. It's hard to pay attention. Do you know what it is? Alex, you know what the mistake is?
I think the percentage.
No, tell him the mistake. Eduardo, what's the mistake?
Oh, they're only adding 1.
Yes. Emily, did you hear what Eduardo said?
Yeah.
The standard, what did he say?
It's only adding by 1 instead of 2.
Yeah, because standard deviation is 2. This should be 25. This should be 27. That's it. Okay, that's the mistake. Let's take a look at the other ones. Okay. 23, scientists conduct aerial surveys of seal sanctuary and record the number of X seals they observed during each survey. The number of seals observed were normally distributed with the mean of 73 seals and standard is 14.4. Find the probability that at most, so this is the same thing. You just do the same thing, right? Just set up your bell curve and then answer the problem. I think you guys are good. 25, is this a normal distribution? Is this a normal distribution? Number 25. Let me ask the super smart kids in my class before I ask you guys. Is this a normal distribution? Right here. Is this a normal distribution? Alex, what do you think? You get a
No.
okay, why? Why do you guys think that?
Just, can I see the numbers?
No. Just look at the pattern. That's all you need. Does it look like? Look what that.
Because the numbers, the numbers in the middle, like on the left side, have to be higher. All of them. They have to go down. Can't go up and go down.
Yes. It has to be the shape of that bell curve. Normal distribution is going to look like this. This is just. That's it. That's the main thing. It has to look like that. Let me see if the class gets it. Okay. Is this a normal distribution? Estrella, what do you think? Sorry.
No.
Correct. Why not? Let's see. What I'm like. Let me go back. This right here. Yes. No. Why not?
Because once the one side has more than the other side.
Yeah. Yes. It has to be. It can't be shaped tall and then short. It has to be shaped like a bell curve if it's a normal distribution. So like the one we say on the board, we have here. It needs to be shaped like this. Up and then down. This one just up or increasing, then decreasing. This is just down, right? That's it. So no, it's not. And that's it for today. That's it. Are there any questions? Okay, if you don't have any questions, you can go ahead and go. I love you. I will see you tomorrow. Test is on Thursday. I love you guys. Bye. Let's see, I can't see you saying bye. You guys are going. You guys are out of here faster than I can say
Hey,
bye.
Mr. Sanchez, I do have a question before.
All right, Stephen, go ahead.
So last week I was not here on Tuesday or Thursday, so I was having a lot of trouble with the law of cosines. So I was wondering if you could just give me a quick refresher on the law of cosines, just like the formulas and stuff that you use.
Sure, I'll give you the formulas. It's
Okay.
also on the videos too. Look at Micah.
Oh yeah, the video.
How did you get that on the ball, dude? That's crazy. Let's see. Any other quick questions before I show Stephen? Emily, you're still there. Do you have a question?
Tomorrow I start my college, my dual enrollment, so I won't be here from like 1 to 3 from like now on Tuesday and Thursdays.
Well, I'm gonna have to wait. What? Why aren't you gonna be here, Emily? Emily, why?
I start my dual enrollment classes.
What's that?
The college courses.
Oh, wait a minute. That sounds weird. So, well, I'm not sure what to do. I think I have to mark you absent, and then you just take the video. Just watch the videos. I guess I'm not sure what to do. I mean, if you're not here, you're not here. Let me ask about that. But you have to watch the videos though. It's because you're taking.
All right.
You're going to be watching classes online for your college course too.
Yeah, like 2 times a week we just meet on live, and then we like, I don't know.
Yeah, what class is that?
Some like dance class, something like that.
A stats class?
No, a dance class.
Oh. And did your counselor sign you up with this?
Yes, he did.
Okay. All right, let me find out, but you gotta watch the videos. Or what time is your dance class?
1 o'clock. So I could be here for like a little bit, and then I could have to leave.
Yeah, 12:22. Okay, yeah, at least do that. Okay. All right, and then whatever you miss, just watch on the videos. You're gonna do a
All right.
dance class online?
It's not a dance class. It's just kind of like teaches you about like the history and stuff.
Oh, dance history, dance appreciation thing. All right. Well, cool. Thanks for letting me know. Dual enrollment. Huh? Dual enrollment.
Sensei,
Yeah.
I wasn't here on Friday and I didn't get the code for the test.
All right. Let's take it.
I'm pretty sure the code was Among Us.
That was it. I don't remember all my codes, so try that, Kimberly.
Okay, I will. Thank you.
That code is kind of sus.
That code is the best.
Sensei,
Yes, Brianna.
I just wanted to make sure you got me down for attendance.
Let's see. Is Among Us a bad code? Micah says it's a bad code. Is it cringy? I'm a cringy guy, though. I am a cringy guy. Brianna. It's Brianna. All right, Brianna, I got marked you here.
Okay, thank you.
All right, Steven, you ready?
Yeah.
You guys have any questions? You guys do? Okay, law of cosines, dude. Do you guys remember the law of cosines? It's going to be this. C squared equals A squared plus B squared minus 2AB cosine big C.
So is that the only thing you can use for it? Can you
Well,
only
what is your question? Because
so like if I'm trying to find a triangle and I don't have the angles, right? And I'm trying to find an angle. So say I've got a triangle and
sides.
what?
You just have the sides.
Yeah, just have the sides.
Okay, so let's say you're solving for this angle right here, right?
Yeah.
Okay, so what you do, these letters don't really matter. The main thing you have to know is that, well, first of all, the lowercase are the sides, right? You remember that?
Yes.
And the capital is the angle, right?
Yes.
Okay, so this is my angle. I don't have letters here. I just have theta for my angle, right?
Mm-hmm.
Since I'm solving for this, then it has to be equal to this. This is going to be my C squared.
All right.
If you did it, you'd get the wrong answer. It has to be it has to be equal to the angle that you are given or that you're trying to solve for.
All right.
So then it doesn't matter. The 12 and the 15, you could switch those around. So I'm going to say 20 squared equals 12 squared plus 15 squared minus 2 times 12 times 15 cosine theta. I could have done this, Stephen. 20 squared equals 15 squared plus 12 squared minus 2 times 15 times 12 cosine theta.
Would have
Right?
been the same thing, right?
That doesn't matter.
Yeah. Okay.
It's like the quadratic formula, right? The a squared and the b squared, you can flip those around. That makes sense?
Yeah. So far it does.
Do you want more?
Well, I'm just wondering, so like once you get through the whole equation, right?
Yeah.
And then you got the cosine is theta. How do you solve for, like, when you get through that whole thing and you switch it, how do you solve for the cosine?
Okay, so let's do the whole thing then. Ready?
All right.
20 squared is 400 equals 12 squared, 144, plus 15 squared, I think that's 225.
Yeah.
Minus 2 times 12 times 15.
2 times 12 times
2 times 12 times
360.
Okay, great. 360. Okay, so you got that, right?
Yeah.
Okay, so now add these. 400 equals 144 plus 225. 369.
9. I got 9.
Huh?
I got 9.
You got 9?
Well, from subtracting.
No, don't do that.
Okay.
You just made a big mistake.
Oh, God.
You're fired. Don't even do that.
All right.
Don't do that. Oh, son of a Stephen. Oh, my gosh. Okay, look. Stephen.
Yeah.
Let me show you what you did.
Okay.
If I said, this is the example I've been showing the class. If I said 8 equals 4 minus 2x, how would you solve that? This right here.
I add 4 to the other side and then divide by 2.
You mean subtract 4.
Or, yeah, because it's positive. Yeah.
You would not go like this, though, would you? 4 minus 2 is 2x.
No.
That's what you did there.
Oh, okay. I see it now. Yeah.
This is like an x. So you don't want to subtract these. Just like that, you want to subtract 4 and then divide by negative 2.
Okay.
Okay? So we go minus 369, right?
Yeah.
Okay, so what is 400 minus 369? You calculate that.
31.
31 equals negative 360 cosine theta. So like I did before, now Okay, so the problem, I can't remember. A equals 4 minus 2x. Can you see this down here? Am I low enough?
Yeah, no, I can see it.
Okay, so I subtract 4, then you get 4 equals negative 2x. Then you divide by negative 2, right?
Yep.
So here you're going to divide by negative 360.
All right.
Okay, because that's like my x. So let's divide by negative 360.
And then negative 0.08611.
Like 0.08611. Is that right? Did I write it right?
Yep.
So now you're going to take the inverse cosine. And that should be your answer.
Oh, okay. Because on the tests and stuff, I was like, I don't know what I do now after I find the cosine of it.
You're trying to solve for theta, so to get rid of it, you do the inverse. And that's going to cancel that out. So now you do the inverse. Hopefully this will come out, because I just made this problem up.
Yep, and then I got 94.
There you go.
All right. Thank you. That helped a lot.
Okay, you're welcome.
All right. You have a good day.
Still need to take the test?
No, I already took it.
Okay.
All right. Thank you.
You took it and you didn't know how to do that stuff?
Yeah, sort of. I kind of was looking up certain things about how the formulas.
Don't even tell me how you passed that test.
All right.
I don't even want to know. I don't
Sounds
want to
good.
know.
All
Okay,
right.
I'll see you tomorrow.
Thank you. I'll see you tomorrow as well. I'll be in school tomorrow, actually. So.
All right, cool, man. See you in person.
All right. Bye.
Bye-bye.
It'll work. It can work. It can work.